So, Jai Hind all of you. I am Manish Kumar, Assistant Professor in Department of Computer Science and Engineering College at Ajay Kumar Garg Engineering College. So, today my fourth complex topic is about the backpropagation algorithm. Okay. So, this is one of the most important algorithm that we have used in machine learning techniques. Backpropagation algorithm. So, today in my content, I will introduce you about this algorithm, where we will use this algorithm, what is this backpropagation algorithm. Then I will try to show you with the help of a demonstration ki how we are going to use this algorithm, how this algorithm works. And lastly, I will illustrate you with the help of an example ki how we are going to find the values, different values. Okay. So, we know that artificial neural network, the network which is inspired from the human brain where millions and trillions of neurons work together to store experience in our brain. Several times in my previous PPTs also, in my previous lectures also, I have discussed about this example ki whenever a person, for example, I am going to pick a hot cup of tea, so I will sense a hot, the tea is hot, the cup is hot from outside, because the electrical signals has passed to my brain and the neurons stored there has experience, that hot experience. So next time I am just going to pick the cup, I will pick it carefully because it may be hot, because the experience was stored in neurons. So same the concept, from the this biological neurons, this artificial neural network is inspired, and we know that this neural network has been categorized into several types: feed forward network, multi-layer perceptron model, single layer perceptron model, and one of the illustration of this artificial neural network is backpropagation algorithm. Now the question comes that, now firstly I will introduce you, and the question comes in our mind is that what is backpropagation algorithm, where I am going to use this backpropagation algorithm. So this algorithm is used very efficiently. For what purpose? Used very efficiently to train a neural network. Through a method, and that method is called as chain rule. Through a method called as chain rule. Okay. So simply what happened after each forward pass means we are going to pass some values, matlab we are going to follow some layered approach, because we all know that artificial neural network consists of layers. What are the names of those layers? Input layer, first of all input layer is there, then hidden layer is present, it will depend how many hidden layers are present, hidden layer, and lastly output layer is present. So this comes under the architecture of neural network that I have previously discussed in my previous lectures, right? So what happens, we just going to feed the input from the input layer, okay, and each forward pass through a network. And backpropagation means this backpropagation means this algorithm will perform the back pass. What is the need of back pass? For example, our algorithm generates some output, we have calculated some output, and some desired output is there, means there is a difference between target output and desired output. Okay, so we just want to minimize that error. We want to minimize this error. So for minimizing this error, what we will do? We will just back pass via this hidden layer, then this input layer, then we again perform the forward pass, and again we will recalculate. This iteration will go on. This is the role of this backpropagation algorithm, right? What we are trying to do here, we are trying to adjust the different parameters here in this algorithm, right? What are those parameters? Parameters are weight, we will adjust the weight, and biases. So after adjusting the weight and bias, we want to minimize this difference, that error. Okay, so fastly I just go directly to the topic. What is backpropagation algorithm? So here in front of you, this backpropagation algorithm, the name of the algorithm is backpropagation, right? And we have passed several parameters here. Number one is, obviously we will going to give some training example, the training example which you are going to train it. Okay, eta is a constant that is called as learning rate here. This is very important role here, learning rate. Input, neuron output, and neuron hidden, that I have discussed. Input layer, hidden layer, and output layer. With the help of this layer, the input is passed and output is generated from the output layer, and the lot of processing is done in between that, in between these layers. Okay, so each training example is a pair of form x comma t. This is a vector representation where x is a vector of network input values, right, t, and vector of target network output values. Okay, eta is a learning rate. For example, we will consider the learning rate as 0.05. The value lies from between 0 to 1. Okay, so number of network inputs, and I represents the network input, and hidden represents the number of units in the hidden layer, and out represents the number of output units. Okay, the input from unit I into unit j is denoted by xji. Here I have written it xji. Okay, and the weight from unit I to j is denoted by wji. Right. So firstly, how we will proceed in backpropagation algorithm? We firstly create a feed forward network. Right. This is the first step. Feed forward network. That network will consist of input layer, hidden layer, and output layer. Okay, we will create a feed forward network. Okay, then we will initialize all network weights that is given to us. Network weight is the value of the particular edge. Okay, to some random numbers. Okay, that is given. So until the termination condition is met. What is the termination condition? That I have discussed. Ki until or unless that error is minimized, है ना, we will back pass. We will keep on iterate. So this is the termination condition. Okay, until the termination condition is met, what we will do? We will do for each xt, that training example. Okay, what we will do? Number one, we will propagate the instance x is the input, okay, from the input layer to the network, and compute the output. Give the input and compute the output of every unit in that network. Okay, for example, we know that there are lots of processing elements are there. Okay, so depending on the given example, it is decided how many processing elements will be there in input layer, in hidden layer, and in output layer. Okay, so firstly, after creating the feed forward network, we will propagate the input forward through the network. This is the first step. Okay, see, for example, firstly what we will do, we will just create a feed forward network. So I will try to illustrate this algorithm with the help of example illustration. Okay, number one, so for example, this is my given ANN, feed forward network. Okay, so this is my input layer. How many processing elements are there? 3 processing elements at input layer, 2 processing elements at hidden layer, and 2 processing elements at output layer, and I have numbered them 1 2 3 4 5 6 7. Right, this is number one, create a feed forward network. So this I have created a feed forward network. Okay, then this is the input x1, x2, x3. Input will be provided, and this will propagate in the network, and the output will be generated. Okay, how? This one, the mapping is done here. Input from 1 xi will be propagate here. I have numbered it x41, and weight, respective weight of that edge, w41. 1 to 5 mapping is done, numbered at x51, w51. Similarly, from x2, the input will propagate to 4, the input will propagate to 5. Similarly, from 3 to 4 and 3 to 5. Right, again, this is my input layer, this is my hidden layer. Okay, again the same processing will be done, hidden layer to output layer. This is my output layer. Right, so 4 to 6 input will be this this output layer will get input from the hidden layer. How? Using this same calculation, x64 weight is W64, x74 weight is W74, similarly 5 to 6 and 5 to 7, right? And we will get output O6 and O7. So this is how, this is the forward pass. Okay. Now what happened? We will see some error. Until unless that error is considerable, we will do back pass. Okay. So we have completed this step. Input the instance x, x1, x2, x3. There are 3 processing elements to the network and compute the output. Okay, O6 and O7, right? We have computed the output in the network. Then, now if the error is there, what we will do? We will propagate the error backward through the network. Now, how this error will be propagated? Number 2, for each network output k, calculate its error term delta k. Okay, delta k. OK, 1 minus OK multiplied by Tk minus OK. T is the target output, one is target output and one is calculated output, the difference between them. Okay. Third step is, this is for output layer. Then we will back pass it output to hidden layer. Okay. And for each hidden layer, how we will calculate the error term? Delta H, it is calculated using this equation. OH 1 minus OH into summation of k belongs to output. For each output, it will depend how many processing elements are there in the output. In our case, we have 2 output, O5 and O6. See, O6 and O7. Okay. So for each output, we will calculate this value WH k delta k. Okay. Firstly, we will calculate the error term for the output unit. Keep in mind. Then secondly, we will calculate the error term for hidden unit. Then we will update the weight. How the weight will be updated? Using this equation. Okay, WJI, this WJI plus delta WJI. Some updation is done here. Okay. Now the question comes, how this weight updation takes place. So this updation will takes place a rule that is called as gradient descent rule, or we can call it delta rule. Okay. Using this rule, these weights are updated. These are the calculations that have been taken place using this rule, this method, gradient descent or gradient or delta rule. Okay. And WJI, this weight is updated using this eta delta j x ij. So what is eta here? This is the learning rate that we have taken 0.5 for example. Okay. So how this calculation will take place? So when the input comes from input layer and the input will be taken by this hidden layer, now this will calculate as a linear functions. We will do summation. How it will be done? Summation x4i multiply by w4i. This is first I have written here, right? Plus input from the second processing element to this 4 to the hidden layer, x42 multiplied by w42. This is the second addition, plus x43 multiplied by w43, third one. So we will do summation here like this, xji multiplied by wji, like this. So in expanded form, I have put this value here. Okay. Then we will check what type of activation function is going to take place. Then we will use activation function. So after doing activation function, we will calculate this delta term. Okay. Similarly, from 4 to 6 means from hidden layer to this output layer, the same summation term will be calculated here also. Okay. So we will calculate here O4 will be calculated here, O5 will be calculated similarly. Okay. Okay. Then we will use a activation function. Okay. This is one of the important activation functions. Several activation functions are used. You can see in my previous lectures. For example, this is a sigmoidal function, and it is represented using this equation 1 upon 1 plus e की power minus x. 1 upon 1 plus e की power minus x, delta x. So we have done, I have written here delta. I have written here delta, then activation function is implemented here, right? Same process will repeat for this output also, ठीक है ना? Summation of x64 multiplied by w64 plus summation of x65 multiplied by w65, same has been written here, and O6 and O7 will be calculated, है ना? Now after this the question arises that how we are going to calculate the error term, ठीक है? So error term is calculated two times, firstly for firstly for output unit and then secondly for hidden unit, ठीक है? So it is calculated like this, delta k using this term, delta h, this is for output layer, this is for hidden layer, right? This is for hidden layer, and we will update the weight. So how it is calculated? So for example, we will back propagate. So delta 6 will be calculated and delta 7 will be calculated here, ठीक है? Using what equation? Here delta k है ना, k. So we, how many output units are there? 2. Delta 6 we will calculate delta 6 and delta 7. It will be calculated, ठीक है? Then hidden layer delta 4 and delta 5 will be calculated, okay? And for hidden unit we will use this equation, delta 4 and delta 5, right? ठीक है? Then after updation we will update the network weight wji. That given weight will be updated, delta wji plus wji eta, this is learning rate, and we will put these values and we will update, ठीक है? And this will keep on iterate until the termination condition is met. And what is the termination condition? Again I am repeating, until and unless that weight has been accepted, okay, according to the given problem, right? Now fastly comes, now I just want to show a solved example, back propagation example, ठीक है? So let me assume, for example, neurons have a sigmoid function. What type of activation function I have to use? I have to use sigmoid function that I have discussed, 1 upon 1 plus e की power minus x. This function we have to use in this question, and we have to perform a forward pass and backward pass on the network, ठीक है? Assuming actual output is given 0.5, and using the algorithm we will calculate the output. If any difference is there, then again we will forward pass. The value of eta is given 1 and we have to perform another forward pass. This is the question, ठीक है? So I have just draw a diagram. This is my example that I am going to solve. So here x1 is given, this is the first input processing element, x2 is given here, ठीक है? This is the hidden layer h3 and h4, and this is the one processing element or output layer. So with the help of this simple example I am just try to illustrate how we are going to solve this back propagation algorithm numerically, ठीक है? So firstly what we will do, we will just propagate forward. Firstly we will propagate forward, number 1, first step, ठीक है? So how we will propagate forward? We will do the forward pass. Using forward pass, ठीक है? So what I have to do, I have to compute for forward pass, I have to compute output for this y3, ठीक है, y4 and y5. So I have to calculate this, है ना, forward pass, ठीक है? How we will calculate? You know the formula. For example, I have to find this aj by doing the summation of j, ठीक है, wij या ji, what multiply by xji, input is multiplied with the weight, ठीक है? And how the secondary activation function is used, f of using a function of that j the value that I have got from here, I will use the activation function here, function f, है ना. Sigmoidal in question sigmoid function is given, and what is the equation? 1 plus e की power minus aj. I will use this. ठीक है, right? So let me put the value here. Firstly calculate for this a1. ठीक है, I have done the calculation and I just write it down here. W13, ठीक है, multiplied by x1, right, plus W23 multiplied by x2, right. Now we have to put the value here. W13 is given 0.1 multiplied by x1 0.35 plus W23 it is given 0.8 multiplied by x2 it is given 0.9, right. Then after calculation we will get the value 0.755, right. Now we will apply activation function here, right. So applying activation function fa1, ठीक है, yj activation function है ना. So using this activation function I will just calculate y3 here ना. So it will be calculated using activation function f. So I will calculate it 1 divided by 1 plus e की power minus 0.755, right. So after calculation I will get the value 0.68, ठीक है. Okay, okay students. So this is I have done the calculation for y3, ठीक है ना. Similarly you will do the calculation for y4, ठीक है. Similarly I will write it down here. Similarly for y4. So I have done the calculation already. You will calculate in the same manner. How this y4 will be calculated? This weight W14 will get multiplied with 0.35 plus W24 that is 0.6 multiplied by 0.9. Then we will do the activation function in the same manner, ठीक है, and I will get the value is equal to 0.6637. Okay, okay guys. Now again I will calculate. Now I have to calculate this y5, and in the same manner it will be calculated. How it will be calculated? y5, the value that I get from here, this multiplied by 0.3, ठीक है. So how this will be calculated? I just do the calculation here using this here. A3 is equal to so I will get here 0.3 multiplied by 0.3 multiplied by 0.68, value is 0.68. This I will get from here na, 0.68. So I will multiply it 0.68 plus for this y4 is calculated here है ना. So 0.9 multiplied by 0.6637 है ना. This will be calculated here. Then again activation function will be calculated here. 1 upon 1 plus e की power minus x. This will be calculated and we will get the value of y5 that comes out to be 0.69, ठीक है. And this 0.69 is my network output. Okay students, network output, ठीक है. This is the network output. Now what we have to do in question, we are given with this actual output is given है ना, and we have calculated the network output 0.69. It means we are going to calculate the error है ना. So error will be calculated as y target minus y5 that we have calculated. So what is the y target here? 0.5 minus 0.69, ठीक है. 0.5 it is given here y target and we have calculated 0.69. So I have just do the subtraction here. After subtraction I will get minus 0.19. ठीक है, okay. So once we calculate error, we will check, what we will check, either we are happy with error or not, ठीक है ना. If not, then we will update the weight. ठीक है. So how the weight, now we will update the weight, है ना. So how the weight will be updated? Yes, weight will be updated using this equation, na, right? So we have to use this particular equation. Delta Wji is equal to eta of delta J OI, right? So we know that this delta J is equal to OJ 1 minus OJ, then TJ minus OJ. This is my target output, this is my calculated output, है ना. This is for output unit, right? Again we will calculate OJ 1 minus OJ summation for all output unit, ना, delta K W KJ, ठीक है. And here if J is a hidden unit, here J is an output unit, here J is an hidden unit, right? You know that where eta is learning rate constant, TJ is, this is my correct teacher output for unit J, and delta J, OJ is calculated output, ठीक है. This is my target output, right? Delta J is error measure for unit J. We are going to find the error measure, ठीक है. See, so we have calculated y3, y4, y5, ठीक है. So now what we have to do, we have to perform the backward pass, है ना. Backward pass. How the backward pass is done? For backward pass we need to compute delta 3, delta 4, delta 5, ठीक है. As in the, this is for output unit, this is for hidden unit, ठीक है. Delta 3, delta 4, delta 5. So first of all we will calculate for output unit, right? How it will be calculated? Delta 5, I will put the value in that given equation, ठीक है. 1 minus y target minus y, okay. So the value of y is 0.69 multiplied by 1 minus 0.69. Y target is given in a question, 0.5 minus y 0.69. So I have put the value here and get the after calculation I will get 0.0406, ठीक है. Then we will check for hidden unit, ठीक है ना. After keeping the values in hidden unit I will get the value here, ठीक है, and the value will be calculated for delta 3, ठीक है. I will put the value here, y3 1 minus y3 multiplied by w3 5 multiplied by delta 5. So after keeping the values, respective values, I will get the here value 0 minus 0.00265. So after putting the values you will check the values here, ठीक है ना. Similarly for H4, for this, similarly for delta 4, ठीक है. For delta 4 when we will put the values I will get a value minus 0.0082, ठीक है ना. So we have calculated error at output unit, है ना, as well as at hidden unit, है ना. Now using this we will modify the we will modify the weight. ठीक है ना. Now how the weight will be computed? Same delta W terms will be used here, है ना. So for example, weight will be calculated delta W for 5. I will just show you the illustration of this. ठीक है ना. Eta delta 5 and y4. ठीक है ना. So I will put the value here. The value of eta is given 1. Delta 5 value we have already calculated, minus 0.046, right, multiplied by 0.6637. So after calculation I will get the value minus 0.0269. ठीक है ना. Similarly weight will be calculated from hidden to input unit 14. Delta 14 will be calculated. Eta delta 4 and x1. ठीक है. And after keeping the value I will get minus 0.00287, right. ठीक है. The new weight will be delta W14 old 00287 and it will be added into old weight. Old weight is 0.4, that is given. ठीक है ना. And we will get a new weight 0.3971. This is the new weight. Okay, this is the old one. This is the value that we have calculated and we will get the new weight. Okay, so I have just shown you via this example. So you will keep on calculate. See here, this illustration I have shown you here. ठीक है. So in the same manner you can update the value of Wij, है ना. Now if we are satisfied then it's okay. Otherwise we will do the forward pass. ठीक है. So this is the diagram here. ठीक है. तो same process is followed. ठीक है. तो after same process again we will do forward pass. These are the updated values. ठीक है. If we are satisfied then it's okay. Otherwise we will again do the same process. So we will again calculate A1. I have calculated A1 here 0.7525. ठीक है. Calculated the value of y3. Again I have calculated the value of y3. You can check it out by calculating the same procedure 696797. ठीक है. A2 value is coming out after calculation 0.6723. ठीक है. y4 is coming 0.6620. you will check it out. ठीक है ना. my previous value is y5 0.69 and the new value is coming out with the help of this y5. if we calculated the new value is coming out 0.6820. this is my new network output that is coming now. ठीक है ना. if we are satisfied then it's okay. Otherwise we will again check the error. ठीक है. error is comes out to be minus 0.82. this error is coming. say na y target minus y5. so using this error is coming. if this is satisfied then it's okay. Otherwise we will keep on iterating. ठीक है. so this is the solved example that I have shown you here. you just practice, है ना. and if any problem exists then you just review this PPT again. okay, thank you.